Hey guys, today we'll be solving LeetCode number 1340, Jump Game 5. This is a hard question on LeetCode and this is the daily problem for today as well. Now today I'll be doing something different. I'll be coding in the language C, right? And with this I'll be explaining it very simply, right? That's the thing. Explaining part will be very similar. You can code up in your own primary language. I'm sure you won't have any issues with that. If not, you can ask AI, convert it to the equivalent code. And I've written up the code already, but what I'll do is first I'll explain the question itself, then I'll talk about the approach, and then I'll explain what the code itself does. The code itself is not so big. In this question, it's really just figuring out the pattern that you need to use and the constraints. So first off, what is jump game? Jump game is jumping to any index. If you've done any of the previous parts, jumping to any index is how you can sum it up from current index, right? And this jumping to any index comes with a constraint. In this question, our constraint is the integer value d, right? This is our constraint in the sense that I plus x, I minus x over here is bounded to d, x over here is also bounded to d. Keep in mind, you can't go out of bounds in either of those cases, right? You can't go out of bounds in either of those cases. You just can't do that. And they're bounded to d in the sense that if we were given d3, then it would be I plus 1, I plus 2, and I plus 3, and the equivalent for minus. Okay, so now let's consider the question itself, the second condition of this question. Let's consider a buildings array over here. Okay, so I have this setup. Yep. And what I want you to imagine when I'm going through this is you are a normal human. Okay, first of all, you're a normal human. You have no superpowers, and you've been told to do parkour. Okay, you've been told to do parkour, and each jump you do, right, gives you $100,000. And if you're a greedy person, right, obviously, if every jump gives you $100,000, you want to maximize the number of jumps you take, right? That's obviously what you want to do, right? But you remember that you are only a normal human being, and you can't take risky jumps. Risky means no. What are risky jumps? Okay, so jumping to a building greater than you, that's literally not possible for you. You're just an average Joe, right? You can't jump to a building that's higher than where you are unless you have some superpowers. And the other is equal. Why? Because you are an amateur and you can't judge the distance, so taking that jump for $100,000 would just be not wise, essentially. Okay, so given these two conditions, how do we try to maximize our jumps? That means that the only jumps that we can take are the ones that we go down, right? That's the only ones that we can take. Okay, so we start off with a jump for every single one, right? That's how we start off. I know it would make more sense to have it be 0, but the question itself for some reason has this constraint of 1. Maybe because it took you some jump to get to the building, I'm not sure. although that's not possible, but it's just a quirk of the question. So everything starts off with 1, and we have to consider every jump that we can make within D. So if we start off 0, 1, 2, 3, 4, if we start off at 0, come here, but we see that we can't jump there, it's out of bounds. Can we jump to a building that's greater than us? No. Can we jump to a building that's greater than us? No. But over here, we can jump to a building that is lower than us, right? So what are the maximum number of jumps you can take from this position? 1 plus 1, 2, right? Now let's come to this building over here. Can we take a jump over here? It is equal. It is equal. Can we take that jump? No. But can we jump to the left side? Come over here. Come over here. We can. How many did we take? 1 plus 1, 2 plus 1, 3, right? We took 3. That is our maximum that we can get from here. Now let's consider this. Can we go to the left? No. Can we go to the right? Yes, absolutely. Took 1 jump. We're sat at 2. Can we go another jump over here? We can't. Can we jump backwards? No, we can't. So we're stuck at 1. Now, one thing you might have noticed is the fact that there is a very deliberate reason as to why I wrote 2 plus 1 and not just 3 immediately. It's the fact that 2 comes in like this, 1 comes in like this as well. So the thing is, what the index that you jump to, right? If we had it pre-calculated to some value, and that value was the maximum for it, then, and we were able to jump to it, that means essentially we can take up its value, right? It would not be wrong to do that because it's already maximized, right? It is in our best interest to do so. So we would take its value, or we would take over its value, right? And where do we see these types of patterns? Well, see these in recursion with memoization, where we might have to use a previously solved problem's value over again. This comes under the dynamic programming category, by the way. And another thing that kind of gives it away is the fact that you will have to sit at every single index and calculate every single value, right, to try and maximize it. Otherwise you wouldn't get a proper maximized result. Okay, so now that the question itself is out of the way, like I said, we go left, we go right. Okay, so that's what the code is also about. I have written over here max jumps. Okay, this is the entry that you will get. You will probably get the array and D by itself, but for me I get an array size, right? Because C, you essentially can't get the array size without knowing, well, you can do a size of division, but usually they just give you the size. Okay, that's irrelevant to the question itself. Over here I'd have a global variable. Okay, I've declared a global variable, int n and int memo. By the way, this means pointer. You can think of it as this, although it is wrong to say that it is like an array. Just think of it for like that for now if you're not experienced with C. But yeah, just think of it as an array. And what I do is I also make a memoization array, and I set it all to -1, -1, -1, -1. Okay, no values calculated, and I will go through the array itself. I have a result set up here. Go through the array itself, and I see that, hey, the result will just be the maximum of my current result and this jump array ID. Now let's get to the jump itself. What is this jump function? We take the array, we take the index we're on, and we take the our bounds essentially, right? The first statement over here, if we've calculated this value before, in the sense that it is not -1, remember I initialized it all to -1, right? So if it has been calculated, I will move it away. I'll do that later, but if it's no longer -1, then I can just return the value because I have calculated it already. It's kind of like this point, right? Now I go to my left, so I have my result 1, right? We start off at 1, go to my left, so I go from I minus 1, right, to 0 and I minus d, whatever is the maximum between them, because I don't want to go out of bounds, right? It will stop wherever in that way. I j minus minus because we're trying to go left, and if at any point we meet a building that is taller than us, we stop, we break, okay? If not, we add ourselves and we call the function over again to let the recursion fairy do the trick, and we just fetch the result, the maximum of that. Then let's go to the right side now, and j equals to I plus 1, j is less than or equal to minimum, and minus 1, that is essentially not going out of your length, right? J plus plus, we're going to the right. Any point that the building SR break, store your maximum, and at the end set your memoization index to that result so that you can return it later over here, and return your result to keep the recursion fairy going, right? Keep in mind +1 and we start at 1. That's pretty much it for the coding part. Actually I explained the whole code, but the microphone was off, so, and I don't have much time today, so I just went with it and I gave an on top explanation on the code.